So hello, welcome guys. So today we are going to see the first two questions of our NCERT exercise of the chapter electrostatic charges and fields. So we divide electrostatics into two chapters, that is the first chapter which is electrostatic charges and fields, and the second chapter as electrostatic potential. So in the first chapter we discuss about the charges, its nature, its properties, then electric forces, electric fields, etc. And in the second chapter we study potential, its relation with fields and forces, etc. So basically in this video I am going to discuss about the first two questions of our NCERT exercise. So before going to the question, we just simply seeing that what is the Coulombs law. So basically the Coulombs law states that if there are two charges in a medium separated at some distance, then the force between them is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So what the Coulombs law states, we see it pictorially as, so here if I consider here two charges, let plus two positive charges, here it be q1 and here it be q2. So and the distance between them is r. So the force on q1 and q2 will be equal and opposite. So if q2 exerted a force on 1 and q1 exerted a force on q2, then there will be equal. So if the F12 with the force on 1 due to 2, and here it is F21 which is the force on 2 due to 1. So according to the Coulombs law, the force will be directly proportional to the product of the charges. Here we consider the charges to be q1 and q2 as in the pictorial explanation, and inversely proportional to the distance between them, square of the distance between them. Here the distance is r. So the force will be directly proportional to q1 q2 and inversely proportional to r square. So here we have a proportionality sign. So if we remove the proportionality sign, then here it will be a constant. So F is equal to K some constant, which is the constant of proportionality and which is generally known as the dielectric constant, which is a property of medium, and q1 q2 divided by r square. We have to remember the value of K, which is basically 1 by, this is 1 by 4 pi epsilon naught, and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so we get what is the K. So if we move to the question, first question, then here the first question is, what is the force between two small charge pairs having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in the air? So if we see the solution, then here we consider q1 to be 2 into 10 to the power minus 7 and Q2 to be 3 into 10 to the power minus 7 coulomb, and distance is r, which is given as 30 centimeter, and if we convert it into meter, then it will be 0.30 meters. Now, according to the Coulombs law, here we are given to find the value of force. So we know F is equal to 1 by 4 pi epsilon naught, which is nothing but K and Q1 Q2 upon R square. So if we put the value of K, then Q1, Q2 and R square, we get the value to be 6 into 10 to the power minus 3 Newton, which is repulsive in nature. Why repulsive? Because here Q1 is positive, Q2 is positive. So if there are two positive charges, then here we can see that they are repulsive in nature. The force is repulsive in nature. Again, if we have a negative charge and a positive charge, their force is always attractive. The force is always attractive. Okay, so if we given Q1 and Q2 are, then we can easily find F. So the next question, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in the air is 0.2 Newton. So here basically we are given with the force. So the force is given. Here the value of F is given. The value of F is given, and we are given the charges. We are given the charges. Okay, so we have to find the distance between the two spheres. We have to find the distance between the two charges. That is the R. Okay. If we move to the solution, then the solution here we consider Q1 as 0.4 microcoulomb. If we convert it into coulomb, then 0.4 coulomb will be 0.4 into 10 to the power minus 6 coulomb. We know if there is microcoulomb, then if we convert it into the coulomb, then it will be multiply. If we simply multiply the value with 10 to the power minus 6. Okay, then similarly Q2 minus 0.8 microcoulomb, which if we convert into coulomb, then it will be minus 0.8 into 10 to the power minus 6 coulomb, and the force is given in the question 0.2 Newton. We have to find the R. So according to the Coulombs law, F is equal to 1 by 4 pi epsilon dot Q1 Q2 by R square. So if we subject R square here, so the value will be 1 by 4 pi epsilon dot Q1 Q2 upon F. So putting the value of 1 by 4 pi epsilon naught, Q1 Q2 and the force, we found R square to be 144 into 10 to the power minus 4. Here it will be meters. Here it will be meters. So R is equal to 12 into 10 to the power minus 2. How 12? Because we just simply convert R square into R, which is R will be root R. We just simply root this, square root this, and we get the value to be 12 into 10 to the power minus 2, which is 0.12 meters, which is we can in centimeters.